All right, I'm going to need your undivided attention for this. It's not super difficult, but it's a little difficult. All right, here we go. Let's get started. No, I have no chocolate. What? I did. I erased the whole board. Okay, and? St. Patrick's Day is over. All right, here we go. We need to write a new word. It's called an asymptote. A-S-Y-M-P-T-O-T-E. Asymptote. A line that approaches... Oops, hold on. A line that a graph approaches. A line that a graph approaches. A line that a graph approaches. All right, let's look at what's on this sheet here. Your A term is your y-intercept, so that's where it crosses the y-axis. If your B term is greater than 1, your graph is growing. If it's less than 1, your graph is decaying. This is usually used in terms of money, population, bacteria, half-lives, that kind of stuff. So let's go ahead and graph our first one, y equals 2x. All right, I'm just kind of arbitrarily choosing these points, that means randomly. Negative 1, 0, 1, and 2. So this is the same as 2 to the negative 1, correct? Am I allowed to have a negative exponent? So how do I get rid of it? No. It's easier than that. I do 1 over 2 to the first power. And what is 2 to the first power? 2. So your answer is just 1/2. All right, so 1 over 2. So y is 1/2. Anything raised to the 0 power is what? No. 1. Yes. Because it's 2 and our x is negative 1. That's fine. That's a good question. That's fine. All right, what's 2 to the first power? 2. What's 2 to the second power? Let's say you didn't know how to do that. Can you do it on the calculator? All right, grab your calculator. All right, first thing, bottom left corner is on. Top left corner is second. Hit second, please, the green button. What does it say above the 0? All right, so hit 0, please. And now it says reset, yes or no. We want to reset it, so I'm going to hit 2. And it says memory cleared. All right, clear. And does anyone remember how we get to put in the numbers? Where do we go to on the calculator? We did it last chapter. Table. So table is right here. Table. Y equals 2 raised to the raised to is a little caret thing above x squared or below pi. Hopefully you all had a good pi day. Y equals 2 raised to the x. The x is next to the 4. So y equals 2x, and then what am I going to do? Enter, 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 enter until I get a table. Do our numbers match up? Yes? Yes. Okay. Grab your graphing pen. And we're going to plot some points. Yep, I have a special graphing pen. It's purple. You don't? Disappointing. All right, so negative 1, back 1, up 1/2. Over 0, up 1. Over 1, up 2 over 2 up 4. Just for fun, I'm going to go to the left a little bit more. So let's look at negative 2. Alright, so on my calculator it says negative 2 up a fourth. If you just push the up arrow on your calculator, on the oval, if you push up, do the numbers ever go negative? No, they never will. Do you know why they never will? Because there's an asymptote. Where is my asymptote at? It never crosses into the negative, so my asymptote is at y equals, not 1, but 0. So I actually have an asymptote right there. Tote. So now let me grab my graphing pen. And I'm going to try and get it as close to the line as I can without touching. And then like that. So congratulations, you can now graph a asymptote and an exponential function. All right, let's answer the questions down below. The domain. Domain is left to right. Does this graph ever stop going left or right? Nope. So we're going to use that little fancy symbol, the R with a line, extra line, which means all real numbers. The range, we just proved that it never touches the it never touches the x-axis, so our range is y is greater than 0. Now, there's no line under it because it's not actually touching. Johnny, you good with that? Yeah. Y-intercept, where's it crossing the y-axis at? 0, 1. My asymptote is at y equals 0. Well, because we just graphed it and it didn't touch it. In about 10 minutes, Liam, I will explain exactly how we got it. And I'm afraid my pen's about to die.
Just scribble a little bit.
No, I did this yesterday because I started doing this yesterday. It is. But I don't mind that. I'm good with that. I have a ton more of these. I bought more. All right, end behavior. This is the only thing that's even remotely tricky about this. Starting at the center of our graph, also known as the origin, as x, all right, it's done. As x approaches negative infinity. So that's just a fancy way of saying if I start here and my graph goes left, what happens to my y value? It approaches what line? My asymptote, but where's my asymptote at? 0. So it approaches 0, but it never actually touches. So now, instead of going to the left, it wants us to know what happens when we go to the right. So as x approaches positive infinity, as it goes to the right, it goes up towards what? Positive infinity. Good job. Because is it crossing the asymptote? Because it only comes down and approaches the pink line. It never crosses. So it's not allowed to get into negative numbers. All right, take a couple minutes and try the other problem. Remember, you have some smart table mates at your table. If not, it's your bad. You chose to sit with them. Cam, if you need help, I'll help you. Crystal, if you need help, I'll help you. Liam doesn't need help, I can tell. All right, so I'm going to take attendance. Please try this, and we'll go over it in a few minutes. here, 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 not here. Here, 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 here. Not here. Here. Not here. Here, here, here. Here. Not here. Here, 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 here. Johnny is here. Not here. Here, 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 here. See, Colin, I was prepared for such a travesty. Now I just need to decide what color I want, or which one I want. We'll be basic and go with black. Yes.
So when you're looking at the indicators, you always
Usually you start at the origin. That's what I would recommend.
and I can just pick which side I want to go. And then how do you do the opposite?
Now, hold on. You asked where your B is. Your B is actually 1/2. There's no A. A is 1. I'm sorry, what?
And then you want to do like the other half of it.
What do you mean by the other half? I'm confused.
So like you do like second origin, you do the left, and then right,
Uh-huh.
and then after that.
And then you're done. I think.
There's two though.
What do you mean?
There's like X, and then two.
Yep, so X is going to the left, and then X is going to the right. So as X approaches negative infinity, what happens to my Y? And as X approaches infinity, what happens to my Y?
It only goes one way.
Well, it should be going up, and it should be going either left or right. Now, this is a half. A half means it's getting smaller, correct? So that means that we know that since it's getting smaller, our graph should look something like that.
So when X is getting like closer to positive infinity, then like Y is closer to 0.
I'm confused. Let me go over it in just a minute. All right, about 1 minute. X is next to the 4. All right, so Jojo, we're going to do this together. Did you put that in your calculator? Y equals 1/2. Do you have to do parentheses? Yes, you do, because otherwise it's going to do order of operations, and it might not come out right. So I would recommend, maybe on this one you don't, but on the next ones that we do, you definitely have to use the parentheses. So Jojo, did you put that in?
What if I just put in the fraction?
Yeah, that's what I did.
That's fine.
Yeah.
How'd you do that? I don't know how to do that.
Add over.
But do your parentheses. I didn't do it. Don't put your parentheses.
I don't know if I need it or not, because, well, actually I probably do. I see what you're saying.
I didn't do parentheses.
Okay, well, let's try it without the parentheses and just see what happens. So raised to the x. Enter, 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 enter. All right, is 16 going to fit on my graph? Negative 4 is 16 going to fit on my graph? Is negative 3 8? All right, so let's go with negative 2 4. So on my graph here, I'm going to start with negative 2, negative 1, 0, and 1, because that's the first number that'll fit on my graph. So negative 2 was 4, negative 1 was 2, 0 is 1, and 1 is 1/2.
If we started with -1.
Yeah, it's not the end of the world. All right, so now let's graph those points. All right, so back to up 4. 1, 2, 3, 4. Back 1, up 2. 0, 1. Over 1, up 1/2. So on this one, my asymptote is still going to be the x-axis. Not today. Yes, but not today. Well, we'll get there. Maybe tomorrow. All right, so I'm just going to draw on my asymptote, which is right there. So let's answer our questions. Our domain, does it ever stop going left or right? So it's all real numbers. Our range, is it above our asymptote or below? It's above, so it's going to be y is greater than 0. It's not touching, so we don't have a line underneath it. Our y-intercept is exactly the same, 0, 1. My asymptote is y equals 0. Now, from the origin, as I go to the left, it goes up, correct? So it goes up towards positive infinity. As it goes to the right, it approaches my asymptote, but does it actually touch it? No. So that's at y is at, the asymptote is at 0, so y approaches 0, but it doesn't actually touch. All right, just stare at the board and pretend you're paying attention, please. I mean, pay attention and stare at the board. Oops, hold on. Wrong board. There we go. Determine whether each function represents exponential growth or decay, then find the growth or decay factor. Well, if we look at our notes, it says right here that growth occurs when you're greater than 1, and decay occurs when that is less than 1. So if we look here, is 5 greater than 1 or less than 1? So this is not, it's not decay, it is actually growth. And what's my growth factor? That was really not that difficult, was it? This one, 2/7, is that less than 1 or greater than 1? Less than. So this is not growth, but by 2/7. 4/3, is it greater than 1 or less than 1? It's greater than, because as a decimal would be 1.33333, so that is obviously growth by 4/3. 1.05, is that greater than 1 or less than 1? So that's, once again, that is growth by 1.05, and 0.85, is that less than 1 or greater than 1? Less than, so that's going to be decay, so that your graph's going to be going downhill. All right, that wasn't too bad. All right, don't flip your paper over. Let's slide our paper down, though. We need to add some notes to our paper. So just somewhere over here in this space, I'm going to write y equals a, I'm going to use a dot for times, b, in parentheses, I'm going to put x minus h. And then down on the same level as the a and b, I'm going to put plus k. Have you ever seen anything similar to that before? Yes, you have. When we did vertical form with polynomials or quadratics, we did this. And if you remember, this is in parentheses, so therefore it is a liar. So what that means is it controls left to right, but if it's positive, it goes left. If it's negative, it goes right. K is not a liar. It controls up and down. Positive is up, negative goes down. Once you are done writing that, please flip your paper over. Unfortunately, I did not plan ahead and did not put graphs on here, so for that I apologize. So what you need to do is draw a graph. Just it doesn't have to be as good as mine. Remember, I'm a trained professional. Nope, one like that. Magic. Math-a-magic. Or as Dr. Strange would say, it's not magic, it's math. I did. I sent him Mr. True when he didn't respond. I don't think so. Hold on. Dinosaurs. What's it say? You're what?
You're dynamite.
Dynamite. Got it, like dinosaur. That's pretty clever. It's pretty funny.
I got flying face for him.
Flying what? Nice. Alright, so this is what we're graphing now. I'm going to put it above it. Y equals, I'm going to put the 2 in parentheses. And then above, I'm going to put x plus 3 minus 4. You can't see it.
So it's like using for like x minus 3 or no?
I'm sorry, say it again.
Could it be what equals to the power of x minus 3? Or
Yeah, x plus 3.
because it's not in the
Yeah. That's what I was just looking in the book to see exactly how they wrote it. So give me 1 second. They did not put any of it in parentheses, actually. So, yeah, they just have 2 not in parentheses, x plus 3. But when we go to put it in the calculator, I would highly recommend putting it in parentheses. So here we go. Grab your calculator, please. Actually, before we even do that, we're going to draw our asymptote. This tells us it's going to be left 3, correct? So I'm going to go left 3, 1, 2, 3, and I'm going to draw a straight line.
You just try to draw a straight line.
Yeah, just try and draw a straight line. And then also it's going to be down 4. And I'm going to draw an asymptote there too. 1, 2, 3, 4. Okay, I was close. All right, grab your calculator, please. Yep. Yep, because this is left to right, so I went negative 3. And this is 4 down, so I went down 4. All right, I'm going to do second reset on my calculator just to get that other stuff out of there. And then I'm going to hit table. And then I'm going to do 2 raised to the, now I'm going to put this in parentheses. X plus 3, what? So you can't see that, let me move that up. 2 raised to the x plus 3. And then go click to the right to get down so that you're on the same level. Minus 4. So you should have something that looks like that in your calculator.
You did put them in parentheses?
I just put the x plus 3 in parentheses.
And do we start at 0?
Well, I'm going to look at my numbers and see what makes sense.
Okay, because it starts at 0 and then the y is equal.
Okay, hold on. Enter, 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 enter. All right, so if you look, what's the only one on there that'll really legitimately fit on this graph? 0, 4, right? So let's graph 0, 4. We're going to go smaller. Give me just a second, Kate.
So 0, 4 and then go back.
So let's go 0, 4, 0, 4, 1, 2, 3, 4. And now let's look at the negative numbers. Negative 1, 0. Let's go to the next one. Negative 2, negative 2. And really what I want to do is go down until I get to almost my asymptote, or it starts to flatten out. So let's go negative 3, negative 3. 3. 1, 2, 3. Well, it's not allowed to hit the asymptote. It gets close to, but doesn't actually hit. All right, so negative 4. What's negative 7 halves the same as?
Negative 3.
Yeah. Did you not get it on your calculator? All right. When we're done with this, I'll come and figure out what's going on there.
So when we're looking at the asymptote, we're only looking at the line at the bottom, we're not looking at the vertical.
Right. I'll show you what happened to the vertical one in a minute.
Okay, because I thought that the 3, 3 hit the line. That's why that's not.
Nope. So negative 4. 1, 2, 3, 4. Negative 7 halves is the same as negative 3 and a half. Negative 3, or negative 4, that was negative 4. And then what's happening, it's starting to flatten out now, correct? So that's fine. So just draw your line here. And then go up. I'm not getting out my magnifying glass to see if you got it exactly right. Just get it close. There we go. And congratulations, you just graphed that. I think I did. 7 halves is the same as negative 3.5. Yep. I thought there was a way to do it on your calculator, but it's not doing it.
Usually, if you get like a scientific one, there's like an SD button.
There is. There's an F to D button. I don't know why it's not changing the fraction decimal. I'll figure it out next period. And I'll show you tomorrow. All right, final problem for today. You're graphing this. Hold on, I think this is the final problem for today. Not today. We're not done with the lesson. All right, try and graph that one, and then we're done for today. Yes, I'm old. I am.
I think you're like early 40s.
You're awesome, but no. What's going on here? Let's go back to this. First of all, turn it on. That helps. Let's go back. So 1/2 to the half. Fine. Stop right there. Take the 1 to the half. 0. Borrow. Perfect. Figure that out. All right, it's kind of hard to put in. My one is my daily 500 in the second. Okay, with that, that's negative 1/2. I'm going to do parentheses 4, close my parentheses. Yeah, up arrow. Yeah. What is that? X code 4. I got really close it. And now I need to go down back to the 4 level.
Yeah, negative 1/7. So it's a negative.
I just did it for the calculator.
But I was going something positive, but I started getting to 8,000.
I put the X plus 4. I think so. That should work. And now, obviously, those are some weird numbers, right? I would just graph like -4 back. Exactly. Just literally graph 1, 2, 3, and then I'll show you how to fill it out on the board.
Yes. I don't know. Let's see. I don't know. I'm doing it right now. So I'm just putting it back there right now. So -1/2 raised to the parentheses x plus 4. Scroll to the right, +1. And you get some really weird numbers on this one. I know that. Oh, uh-oh. That might not work. No, it's not going to draw on there. So I'll have to do it on my paper. That's fine. That's fine. It'll still look the same. I'll show you. You really don't. We're not being that fussy. This isn't Carnegie, which would mark it wrong if you were off by a fraction of a centimeter.
I need that little thing. Where did you get that?
Office Depot. All right, so let's go ahead and graph it. Now, I know that my asymptotes are going to move. I know it's going to be to the left 4. Yep, that determines your asymptote. And then it's going to be +1. I didn't do very good drawing that. Let's try and fix that. All right. Well, remember, if it's in this is a liar, so it's actually left 4. All right, let's try and graph those points now. Back 5, 1, 2, 3, 4, 5, and 7/8 is going to be just short of 1. So it's just shy of 1. Back 4, up a half. Back 3, down 1. It's just short of 1. It's just short of 1. Okay, so it's like 87%, 87.5% on the way to 1. All right, so just below it, -2, -7, 1, 2, 3, 4, 5, 6, 7. Obviously, -1, -31 is not going to fit on my graph. And the reason we drew our asymptote is because we know it's going to be right up next to it, but not actually touching. And congratulations, you now know how to graph exponential functions.
Do you want us to turn these in?
No, these are your notes, so you're going to actually keep them.